Welcome back. In this video of Answer With Me session, we'll look into another combined science paper code 5129 of paper 1, May-June 2011. I'll only walk through the physics section, which only consists of question 1 till question 13. Okay, let's go. Question 1. A plumber needs to measure the internal diameter of a water tap as accurately as possible. Let's underline that. Which instrument should be used? Let's go through one by one. A. Measuring tape. Wait, hold up. Water tap is something like this. Just in case some of you doesn't know. Let's just pretend this is a water tap. Yep, my so-called water tap. So, what we are supposed to measure is this internal diameter within this tiny gap. Yep, within this tiny gap right here. So, which instrument should be used? Let me repeat again. So, A, measuring tape. You can measure it, but you can't measure it as accurately as possible, as the question asks here. So, it is possible, but not possibly accurate. So, B, meter rule. You can measure again, but it is not the accurate way of measuring it, so B is out of the equation. C is micrometer. Micrometer does not have internal caliper. You need a caliper which can measure internally. Hold up, that doesn't look like internal caliper. Supposed to look somewhere like this. Yep, so you'll be measuring internally within this range. Micrometer does not have this function. This only applies to vernier caliper. So the answer is D, vernier caliper. Calipers. Okay, English wise. Alright, moving on to question 2. A speed time graph for a car starting from rest is shown here. As you can see this diagram. Whoops. Okay, this stylus does not work properly. The graph is plotted with speed against time axis. What is the acceleration of the car between 4 seconds and 8 seconds? So the keyword here, 4 seconds and 8 seconds, from here till 8. As shown by this flat line right here. So, the question asks, what's the acceleration between this 4 second to 8 second of this flat line? First, we need to know what's the formula of acceleration. We know that acceleration is change in velocity divided by change of time taken. In this case, it's speed instead of velocity, but it's okay. We just need the numbers. We can solve this numerically, or we can solve this qualitatively. Let's solve this numerically first. By numbers, I mean. So let's take 2 points. First point is this, and second point is here. Let's figure out the so-called coordinates here. So the first coordinate is 4, 20. Second will be 8, 20 as well. So with these two coordinates, or so-called values, we shall now input into this formula A is equal to change of V divided by change of T, which you can split up to V2 minus V1 divided by T2 minus T1. You can use any of these coordinate as 1 or 2. Either way is fine, but I would like to use a larger number as the second one and the smaller number as the first one. So the second coordinate, which is 8, 20, the velocity is 20, minus the first velocity is as well 20. We divide by time, which is 8 minus 4. We have 0 divided by 4, which is equal to 0 meter per second square. Okay, that is solved numerically. Yeah, that is solved numerically. So another way I can show you is by seeing it qualitatively, which means we just look at this line which is horizontal. Gradient of any horizontal, how do you spell horizontal? Okay, horizontal line is 0, and gradient of this graph is equal to acceleration, as we know from here. We can equate this equation to m, which is gradient, change in y divided by change in x. So this is similar, just different notations or different letters involved here. Okay, so the answer here is 0 meter per second square, which is A, right here. Okay, next, question 3. A rectangular metal block measures 4 cm by 5 cm by 10 cm. The mass of the block is 800 grams. What is the density of the metal? Okay, first of all, density, which is denoted by rho here, is equal to mass divided by volume. We know our mass. Mass is 800 grams. But we do not know the volume. But we can figure out the volume by using the volume or the measurement shown here. Volume is equal to length times breadth times height. Or we can just copy paste this number and just substitute it to the volume. With the use of calculator, you'll be able to get 200 centimeter cube. 800 grams divided by 200 centimeter cube, that'll give you 4.0 grams per centimeter cube. So the answer is C, 4.0 grams per centimeter cube. Okay, moving on to the next page, on to question 4. Let's zoom in a little bit. All right. A horseshoe can be made from a piece of metal by first heating, then hammering the metal. Which property of the metal changes during the hammering action? Okay, let's go through all the options here. A, density. B, mass. C, shape. D, volume. Okay, the obvious change in the properties of metal during the hammering will be C, the shape. Other options shows density, which involve mass, and volume. These two variables will not change at all. Here also will not change, the mass will not change at all. unless you chop off the metal, but that will not likely to happen. Volume will also not change. Okay, going back to density. Density will only change when you switch the metal, the different types of metal. Other than that, they'll not change at all. So the answer will be option C, shape. Okay, next. Question 5. A box is subjected to a force of 60 Newton and moves a distance of 15 meters in the direction of the force. What is the work done? Okay, we have 3 key points or 3 keywords here. First is the work done. Second is the force. Force is given by 60 Newton. And the third is distance. Distance is 15 meters. Oh dear. Okay, my cat just meow. Okay, it's okay. We have work done equation, which is also denoted as sorry, force times distance. We know our force. Force is 60 Newton. We know our distance. Distance is 15 meters. Multiply that together with the use of calculator. That'll give you 900 joules, which is also option D, 900 joules. Okay, moving on to the next question. Question 6. Density changes are responsible for which method of thermal energy transfer? A. Conduction only. Conduction only occurs in Conduction only occurs in solids. We know that solids has the least or is least likely to change in terms of volume. The least change in volume due to their strong intermolecular force. Next is convectional current. It occurs in fluids, or also known as liquids and gases. This too has comparably, okay, let me write here, comparably less or weaker intermolecular force between the particles as compared to solids. Radiation can travel through vacuum, and they are absorbed by all states of matters, but not as much as conduction and convection. So I'll rule out the option C and option D because they are not all the same throughout. Okay, which leaves us to option A and option B. Okay, since we have identified that the solid has the least change in terms of volume, so option B will be the answer. We can see from a experiment, if you guys are exposed with this, you have a Bunsen burner here. You have a maybe beaker filled with liquid or water. Just make it water for now. You have a potassium permanganate here. So this potassium permanganate is directly on top of the Bunsen burner flame, and the potassium permanganate will have the color dye or the purple color travel around the liquid or the water. So that is also density change, where hot water rises and cool water sinks. Let me write it here. Hot water rises, cool water sinks. Same goes to air, but I'm not gonna show that here. Alright, moving on to question 7. The diagram shows the displacement across a wave pattern. Which value is multiplied by the frequency to give the speed of wave? Alright, they're asking what is multiplied with frequency to give you the velocity. As we recall, velocity is frequency multiplied with lambda. What is lambda? Lambda is the wavelength. And wavelength is defined by the complete wave of one cycle. Hold up. Is that the correct term? Do I have to look up the term again? Okay, the correct term will be, okay, let me redo that. Wavelength is defined by the distance between two successive crests or throw. I don't know how you pronounce this, but yeah, it is spelled like this. Or any length between 2 points, such as here to here, or here to here, or here to here. Okay, I don't think you can identify that. Let's just go on with the options provided here. Let me erase everything first. Let's go through one by one. A is not wavelength, it is instead amplitude. So A is out. B is half of the wavelength because it did not complete one cycle or one complete wave. So this is out as well. C, it stretched from here till here. So this is one wavelength, which is what we wanted. But let's go to D. D is from the maximum throw or crest to the maximum but negative crest. So this is, I'll say, twice the amplitude. Which is not what we wanted. So C will be the answer. Let's highlight that one. Alright. So C will be the answer. Moving on to the next page, which is question 8. Alright, question 8. Okay, this stylus is really terrible. Alright. The diagram shows the path of a ray of light traveling towards and into a pool of water. 4 angles are labeled. We can see right here, the diagram is shown here. Which 2 angles would be correctly used in the equation? Sine I divided by sine R equal to a constant. So before we move on to the options, let's have a look in the diagram here. So here we have PQRS. We have the incident ray and we have the refracted ray. So incident ray, let's use blue line here. This is the incident ray. And let us use a different color. Let's use green as the refracted ray. Green as refracted ray. Alright. Now let us move on to the angles. How do we see the angles here? Angles of incident. Okay, hold on. Let me use a symbol here. Angle of incidence is denoted or defined as the angle between the incident ray and normal line. Okay, let us identify where's the normal line. Normal line is the line which is perpendicular to any surface that the ray is traveling towards to, which is this one, the red one. The red one is the normal line. So when we have defined that the angle of incidence is the angle between incident ray and the normal line, so between here and here, we'll have P as the answer. Oh dear. Next, angle of refraction is denoted or defined as the angle between refracted ray and the normal line. So it is between here and here, which is R. So now we know it is P and R. We shall now match in the options below. Let me change the color first. Okay, so A, it is P and R, which is what we wanted. But let's just see the rest. The rest does not correspond to what we wanted, so A is the only answer. Alright, moving on to question 9. Which type of electromagnetic radiation travels at the highest speed through a vacuum? Okay, this is a factual question, so in this case, all of the rays or all of the options here are in fact a part of EM wave or EM spectrum. So all of these three, okay, this is highlighted, hold up. All of these three have the same speed, which is 3.0 times 10 to the power of 8 meter per second. So the answer is D. They all have the same speed. Okay, we're done with question 9. Now move on to question 10. The diagram shows an electric circuit, which is shown here. It looks intricate, but it's actually simple. Okay, the reading of the ammeter A2, which is right here. Wait, where is it? Okay, which is right here. Let's us label that first. 1 amperes, and of A4, where's A4? Okay, A4 is right here on the right side, is 3 amperes. Let's label it here. The question asks what are the readings of the two ammeters, which is the A1 and A3. They're asking for this one, the reading of A1 and A3 right here. So before we get started to anywhere, we shall all know that current in series are all equal. Therefore, since we know that rule, the current in A4 is equivalent to the current in A1, which is 3. Why do I say they are both equal? Because they are in series manner, as you can see right here. Now the tricky part here is when the current enters two branch, which you can see right here. So before it enters these two branch, in the main branch, which is right here, is 3 amps. These 3 amps will then be split into two branches. One of the branch will get 1 amps, so the second branch will get 2 amps. Why? It's because current in parallel circuit will be the sum or the total. I'll write here to make it more obvious here. I total is equal to I1 plus I2, since there's two branches in this case. So the I total here is the main branch, which is 3 amps. The I1, which I'll use the A2 reading, which is 1 amperes. I2, which is the A3, which we don't know. So the A3 is actually 3 amps minus 1 amps, which will give you 2 amps. So now that we know the readings of A3 and the A1, we shall go to the options right here. So A1, as we know, is 3 amps, is shown by option C and D. So the first column, we have 3 in the option C and D. Now we know that A3, the ammeter 3, we obtain 2 amps here. So among the C and D, D has 2 amps under A3. So the answer is option D. Alright, moving on to the next page. On to question 11. Question 11. A 750 watts microwave oven is used in a house where the main voltage is 240 volts. Which fuse should be used in the plug? Alright, the key point here is, okay, another round of highlighter, hold on. Okay, the key point here is the 750 watts, which is denoted by power. Let me write P is equal to 750 watts. And the second one will be the volts. V is equal to 240 volts. Fuse rating will always be current, which is I. So we can use the formula P equal to IV and make I as a subject. I is equal to P divided by V. There we can substitute the P and V, which is 750 watts divided by 240 volts. With the use of calculator, you'll be able to obtain the current value, or the value of current. Okay, I got 3.125 amps. And in fuse rating, you will always need to have fuse rating greater than the current that you obtain, which is 3.125 amps. So in this case, option A is out because it is less than 3.125 amps. Option B is 5 amps, which is greater than 3.125 amps. So this is possible. Option C and D, it is too much of a fuse. What I mean is, it is wait, hold on. How do I say this? the fuse rating must be greater but not too great, not too much greater than the current that is calculated here. So it must be close but higher than the current calculated. So B is the answer. This is too high. This is even too higher. Oh, too high. Let's just put too high. Way too high for fuse rating. So B is the answer. Now next, on to question 12. Which nuclides or nuclide have equal numbers of neutrons and protons? Okay, in order to obtain the neutron and the proton number, proton is direct. You can just read it off from the nuclide right here. But neutron, you need to calculate. So before we get into each option, let us write down what is the formula to obtain neutron. Neutron is equal to mass minus by the proton number. Mass is always located at the top of the nuclide number. So now we can find each of the individual proton and neutron number. Let us write P as proton and N as neutron. P here from option A is 1. Neutron is mass deducted with proton, which is 1 minus by 1, which is 0. For option B, proton here is 2. The neutron here is 4 deducted by 2, which is 2. Next, option C. But I can stop at option B because the P and the N has the same or equal number of proton and neutron. But let us be sure. Okay, let us go to option C. P here in the option C is 3. Whereas N is 7 minus 3 is 4. Not the same. In option D, in option D, proton here is 4, neutron here is 9 minus 4, which is 5. Again, not the same. So the correct option is B, which is the helium. Alright, last question of physics, question 13. How do the ionizing ability of the beta particles and gamma rays compare with the ionizing abilities of alpha particle? So you're given here beta particle and gamma rays as to compare to alpha particles. Let me write here. This is more of a factual question. We know that alpha has the most ionizing ability among these 3 particles, but they're asking to compare these 2 against alpha particle. So we know that alpha is the most. Second comes to beta. Third, lastly, will be gamma. So to compare between these 3, alpha comes first, beta comes second, and gamma came the last. In the options listed here, the beta and gamma cannot be more than this alpha. So any options with more is counted as out. So the only option which is less right here is the only correct answer, which is A. And that ends our session here of the walkthrough with physics. I end my session with a star in the cloud. I'll see you in the next video.